Okay, guys, so here's more U substitution. So we're going to do 4 problems here. Okay, so here I'm doing an indefinite integral, which is an antiderivative, so I'll need bracket plus c. So I look at this. Is it a one-step? No. Any algebra to be done? No. So now I look for f of u. So I am looking for a function with another function inside of it that's not just x. Okay, and guys, I see it. It is e to the 1 over x. E to the 1 over x. That is the f of u. So what is u? If that's f of u, what is u? It is 1 over x. Okay, so I go down here, I let u equal 1 over x, okay? Which, by the way, is equal to 1x to the negative 1. So if we do ax to the n, so right down here, we're about to do a derivative. And so ax to the n. And let me circle this real quick just to remind myself that I have to replace it. And now I'll do the derivative. So du dx equals, so this is the derivative. So it's negative 1 x to the negative 2. Okay. Now, if you're about to do algebra, you don't want negative exponents. And also, if you have any fractional exponents, radicals would be better for algebra, in my opinion. Okay, so du dx equals 1 over x squared. Okay. So what I'm going to do now, oh, it's a negative, my bad. So what I'm going to do now is I'm going to multiply both sides by dx, but then I'm going to divide both sides. I'm sorry, I'm going to multiply both sides by dx, but also by x squared. And guys, I know I have this like negative. This can go on the bottom. Okay, so maybe that would be better. So what we end up with for dx is that it is negative x squared du. Okay, so back up to my problem, dx is replaced with negative x squared du. Okay. Alrighty. So we need all of the x's to cancel and just have u. Let me put it in parentheses so it doesn't look like subtraction. Du. And then this is e to the u over 3x squared. All right, guys, and it does happen. All right, this x squared is on top. This x squared is on the bottom. They are canceling. Careful not to forget this negative. And I'm going to pull the coefficient out front, which is a negative 1/3. Okay, now, is this antiderivative a one-step? Yes, it is. So I carry down the negative 1/3, brackets plus c. What is the antiderivative of e to the u? It is e to the u. Negative 1/3 e to the 1 over x plus c. That's the antiderivative. Okay. Alrighty, so now f. And we're always going through these steps. Okay, is this a one-step? No. Is there algebra I could do? No. Look for an f of u. So you want to find a function. And guys, it should be one of our one steps. The functions you're looking for should be our one-step derivatives. So we're looking for like a one-step derivative that has another function inside of it. And I see it. It's actually up top here. Or a one-step derivative or antiderivative, I guess I should be saying. All right, so you're looking for a function that is a one-step antiderivative. Secant squared is that, right? Its antiderivative is tangent. But we don't just have secant squared, we have natural log of x inside of it. So that is the u. So the whole top is the f of u, and the u is natural log. Okay. So I let let u equal natural log of x. Let me circle that. I got to change that. So du dx, what's the derivative of natural log of x? It's 1 over x. Okay, so I'm going to multiply both sides by dx, but then also by x. So I get dx is x du. So that is replaced with x du. All right. And now I've got the integral x du 3 secant squared of u over 5x. Okay. And guys, you know that you chose the right u if all of the x's cancel and you are left with a one-step antiderivative. Okay, so those are canceling. I will pull out a 3/5. Okay. Alrighty. Okay, secant squared, is that a one-step antiderivative? Okay, so it is, okay. And guys, if you're ever like struggling, it could help to write a derivative sequence. If you're doing an antiderivative, you are automatically starting here, okay, and you're trying to go backwards. So you ask yourself, you got to know your one-step derivatives. Which one-step derivative gives us an answer of secant squared? Tangent. Okay, so tangent of u would be the antiderivative, or an antiderivative. Okay, so now I know I got a one step. I'm ready to go. Tangent of u is the antiderivative. So this is 3/5 tangent. Okay, for indefinite integrals, you've got to put the u back. But for definite integrals, where you use the fundamental theorem of calculus, then you don't put the u back because because you're just going to get a number. But if the answer is a function, you've got to put the u back. Okay, guys, we're doing it. So part F, this is part G. Okay, one step. Is that a one step? No. Is there algebra to be done? No. Or algebra that I can do? No. Look for an f of u. And I see it. The f of u is this denominator, okay? And what is underneath the denominator, that is going to be my u. I'm sorry, what's underneath the radical is going to be my u. So I'm letting u equal x to the 5th minus 7x. Okay. And I'm going to change that later. Du dx is 5x to the 4th minus 7. All right. I'm going to multiply both sides by dx and then divide by that binomial. Oh, look how nice. Okay, so I'm crossing that off. Du over 5x to the 4th minus 7. Okay. And then I will write this over. All right. 5x to the 4th minus 7 over the square root of u. Okay. There we go. So all of the x's cancel. That's good news. And what's left needs to be a one-step antiderivative. So I've got square root of u on the bottom. So I could rewrite this as a u to the n. So this is 1u to the negative 1/2. Okay. Now, oh yeah, and then we keep going back to the beginning. Is this a one-step antiderivative? Yes, it is. So brackets plus c. Okay, so 1u Now we're adding 1, so to the positive 1/2 divided by 1/2. Okay, so keep, change, flip. So this is 2. I'm going to put the u back in. U to the 1/2 plus c. The u is x to the 5th minus 7x. And you could leave it to the 1/2 power, or you could put a square root. You know, either notation is fine. Okay, one more. Okay, part H. Okay, is this a one-step? No. Can we do it in algebra? No. Look for f of u. Okay, so I see a function, I see an e function with a square root of x inside of it. Okay, so I'm letting u equal x to the 1/2, or the square root of x. Okay, then I'm going to change that dx. So du dx 1/2 x to the negative 1/2. All right, so we've got to do some algebra to solve for dx. But if you have fractional or negative exponents, in this case we have both, or something that is both negative and fractional, you have to convert to a different form. We'll do radical form. Okay, it's in the bottom. All right, so I'm going to multiply both sides by dx, but also by the other denominator. So I'm getting dx is 2 square root of x du. Okay, so let me section all that off. That's what's going in for dx. 2 square root of x du. Okay, now I want to show you something. Because in the next move, when we put a u where this square root of x used to be, a lot of people just automatically also put it in for this square root of x. But that's going to be a problem. You don't want to put u in for both of them, because then this wouldn't cancel. All right, and I actually wrote this down. I thought about this earlier just to show you, because a lot of students, when they're learning this, they'll try that. This is what you would end up with. If you replaced both square roots of x with u, you'd end up with this. So you don't get the x's to cancel. You actually just get a more complicated integral. So what you want to do, guys, is you only want to replace the top square root of x with it. Okay, so now here we got 2 radical x du, and then e to the u over 7 square root of x. And now these will cancel. All right, I'm going to take out a 2/7. Okay, now this is a one-step. So 2/7 bracket plus c. E to the u is the antiderivative. Okay. Now in the next line, I'll just put the u back in. And there it is. Okay.